All right. Thank you, everybody, for coming to SoCon and to our talk. Our talk is titled Manually Enumerating Active Directory Attack Paths with BOFHound. So my name is Matt Creel. I'm a senior adversary simulation consultant at SpecterOps. I've been here for about 8 months. Previous experience as both a penetration tester and a red teamer. Fun fact about me, I'm a very big Impacket fanboy, and I love writing my tools in Python.
Get that back in the podium. My name's Adam Brown. I am currently in the public sector. My title is Chief of Offensive Cyber Capabilities, which means mostly nothing. But I am working on offensive automation and management at scale. In the past, I've been Director of Offensive R&D for private consultancy and done a lot of red teaming, pen testing. So yeah, that's me. Today, we're going to be talking about, obviously, enumerating Active Directory with BOFHound. So we'll get to the background, which is, why do we even need to have this talk? What did we experience that made us build this tool? Talk about our approach, talk about some things you want to keep in mind as you're using our tool or the techniques that we're going to be talking about. And then talk about some of the, the newer features of BOFHound, current pitfalls, and where we're going with the tool. So in the beginning, we were all really cool doing the living off the land thing because there was nothing else to do. Nobody had made any tools yet to make our jobs easier. Using a lot of quote-unquote crude tools like NetExe and DSQuery and trying to piece together this big picture of Active Directory, which the larger the organization is, the more you start to look like this guy in the picture when you're looking at all the logs and trying to correlate, what I've already queried, what information do I have, who's who, what's what. And that was a pretty brutal time to be in Active Directory testing. I was not in it yet, so I'm thankful I missed it. I came in right around the time when people started really building out some cool tools and, moving on from NetExe and DSQuery. Early on, the things people were using was AD Explorer, which came out in the early 2000s. PowerView eventually came onto the scene in 2015, which made life a little bit easier. Breaking down some Windows API calls that you could use to enumerate Active Directory and do some more targeted recon functions. And then we entered this age of enlightenment. BloodHound came out in 2016, and it was an amazing tool, really simplified the workflow, taking it leaps and bounds further than it was. The efficiency for doing Active Directory tests increased significantly. This is a screenshot just replicating an assessment I did not too long ago. So all these intricate attack paths, users owning other users who are members of groups, GP links to OUs, following these massive attack paths that we never would have been able to find. Or maybe you could have. I could not have found an attack path like this doing manual enumeration. So BloodHound made life a lot easier. In 2016 to 2021 was a great time to be doing these kind of assessments. Then we went from enlightenment to this age of EDR and detection engineering that we're in now. So mid-assessment, your tools could just flip on you. CrowdStrike could change everything that it's detecting and start burning stuff. So we had to start being a little bit more careful with how we're enumerating the tools we're using. And BloodHound became, or SharpHound specifically, became a fun thing to look back on, but not so practical, and at least my assessments that I was doing. So we needed some stuff to fall back on so that we could keep doing our operations, keep staying undetected. And luckily the community had been building for a while and really came behind this part of the effort. So we had tools like AD Explorer Snapshot, companion to AD Explorer, to allow us to use Python to convert those dumps into JSON or BloodHound compatible JSON files. Tools like SharpView, EDD, stand-in, also providing some control and some granularity to what we want to enumerate and some information that we need to get, just other methods of doing so. And then finally some manual tools like the LDAP search BOF from TrustedSec, Linux built-in LDAP search utility, and a lot of people I saw, at least on Twitter, falling back to tools like DSQuery to do their Active Directory enumeration, which brought us back to that point in time where we're looking through a ton of logs and trying to piece together the big picture manually. And it's, not somewhere that I personally wanted to go back to, but at the time it was just kind of necessary, came with the territory. So I say all of that to say, if you can use tools like SharpHound that automate the collection of Active Directory objects, then you should. Like, this talk is not meant to say that BOFHound is like a preferred method. BOFHound is just an additional tool to add to your arsenal. SharpHound will always be more efficient and quicker than you could do it manually, so if you can use it, you should. But basically, we were faced with this problem when we were doing red team assessment specifically and trying to stay under the radar. We wanted to be able to collect all that information on Active Directory objects, but we did not want to be tied to specific .NET tooling or .NET tooling in general, which was the main way we were collecting AD data in bulk. We wanted to be able to see session, logged on, local group data without blasting the network with a ton of SMB connections. We wanted to, in that same vein, control the speed and the granularity of the data that we were collecting instead of collecting everything all at once. Because ultimately, we wanted to get back to that phase where we were able to use BloodHound's interface to make our lives a little bit easier. And in doing so, we did not want to have to risk tripping detections or burning our operation just to get the GUI functionality back, because that's not really worth it, right? So we had this problem statement, and I guess to understand this problem statement further, we need to understand what are the methods of detection. So I'll pass it back to Matt for that.
So both from a perspective of like if you're in a situation where you find yourself unable or unwilling to take the risk of running SharpHound, out of fear of, burning your operation, triggering your detection, what are some detection strategies that the blue team can employ that can put you in this situation, but also that you might need to consider when, performing your LDAP enumeration routines manually? So we're going to take a look at 4 different detection strategies. We can kind of break these down between client-side and server-side detections. The 3 of the 4 that we're going to take a look at today are outlined in a Falcon Forest blog from late 2022, so there'll be a link or a reference on the bottom of one of the slides. Would highly recommend checking that out. Some of these are going to revolve around just query logging and taking a look at the specific LDAP filters that are being passed through to the query. On the client side, don't really want to spend too much time talking about the client side detections because these are a little bit less reliable. On the client, these are typically going to revolve around telemetry gathering techniques that rely on ETW or API hooking, and these could obviously be unhooked or bypassed. We could talk about proxying our tooling in so that we're not generating like that same on-host telemetry, or even some new tradecraft that has come out revolving around Active Directory web services. So Falcon Force, again, they put out a tool called SoapHound. It uses ADWS. You're essentially making an LDAP request, but it's wrapped in a HTTP request. So it kind of changes your point of where the LDAP query is initiated to that server side. So you won't get that same ETW telemetry, for instance, that you would on the client side. Server side kind of opens up a little bit more reliability and also some more interesting detections, such as the SACLs and audit policies and the expensive LDAP queries that we'll talk about. So on the client side, most of these slides are going to follow kind of a data source and telemetry on the left side, and our detection query or our strategy on the right side. So for our client side logging, our data source is going to be ETW. There's a specific ETW provider there on the screen, Microsoft Windows LDAP client that you can subscribe to. MDE will do this automatically, but if you don't have MDE, this is something that you can subscribe to manually yourself. This will provide you access to those query filter strings that we're interested in. The detection strategy for this is going to be a little bit more static, a little bit more precise, where we're essentially going to be taking those query filters that we see being passed through the telemetry and comparing it to known query filters that are used by offensive tooling. So for example here, so this is Silk ETW. I'm running this in my lab, subscribing to that ETW provider that we called on the last slide. And we're just simply forwarding the telemetry caught by ETW to the event log. And down here's a screenshot of one of the query filters that pops up in one of those event logs that's being collected by Silk ETW. This query filter here is specific to the new version of SharpHound that runs some ADCS enumeration. So that query filter there is maybe a high fidelity indicator that SharpHound is performing an ADCS enumeration routine in your environment. On the right side, Falcon Force has provided some example custo queries that could be used to trigger alerts. So essentially right here, we've got, it might be a little bit hard to see, but we've got a block of like known static query filter strings. Some of these are going to be related to AD Explorer, some of them SharpHound, and simply just taking a look and see, does this incoming query filter match, one of our predefined known bad rules from an offensive tool? We can trigger an alert on that. So moving to the server side, we can take a very similar approach, but we don't have to worry about the reliability issues that could be caused by relying on API hooking or ETW on the client. So same idea here. We could log these or subscribe to these events with ETW. Another option that we have on the server side is to set up some field engineering registry keys to collect event ID 1644. Those look like this, and over here, again, boxed in, we have a query filter. This one I specifically took from Impacket's finddelegation.py script. I know for a fact that CrowdStrike or CrowdStrike Identity on domain controller is subscribing to some sort of telemetry that grabs these filters, because I've triggered a very high fidelity alert against CrowdStrike with this exact tool. So it's sitting there looking for known bad query strings. Detection on the right side, again, provided by Falcon Force, is very similar. A couple smaller where clause because we're doing this on the server side now, but we're just taking those query filters, seeing if they match anything that's known to be commonly malicious. Getting into some of the more interesting or behavioral-based detections. So SACLs and audit policies. If we actually go ahead and set SACLs on user group and computer objects that are descendants of the domain, we can collect events that get generated each time those objects in LDAP are read. So that'll generate LDAP event, I believe, 4662. And our detection strategy here is going to be a little bit more complex, but it's going to involve essentially taking a baseline of every user in the environment, what type or how many objects they're querying over a look back period, and then raising an alert if they exceed that previous maximum by a set factor, so maybe 50x, and over a minimum threshold. So here's one of those 4662 events on the left side. This is for a read property access triggered on a user object, and that GUID matches this part of the custo query for a user object being read. It might be a little bit hard to see, but at the top, they're defining some constants. So we're looking back 14 days to calculate that previous daily maximum number of objects read. And then within one single day, we're looking to see if they exceed that by a set static factor of 50, and it's over a minimum suspicious count of 20,000. So obviously, those constants could be played around with per environment, but an interesting detection that doesn't rely on those very precise static strings, basically. Last one we want to talk about is expensive LDAP query logging. This is one of the conditions that BOFHound was actually developed under. So this goes back to those 1644 event IDs. And when you set those up on your domain controllers, there's 3 registry keys that kind of control how those events get generated. And the logs will get generated for one of 3 conditions. You've got long-running queries, which is essentially just queries that take more than n number of milliseconds to process. You've got inefficient queries, which are essentially queries that visit a high number of objects over a threshold and return less than 10% of those. And what's termed expensive LDAP queries, which is simply an LDAP query that returns a very high number of results. So detection strategy could be similar to something on the last slide where we talk about taking baselines in your environment and simply firing an alert if those get exceeded by a specific factor. Here's another one of those 1644 events, and this is actually a query filter from a SharpHound DC only run. This would definitely trigger some of the previous static string detections that we talked about. And down here, you can see your visited entries and returned entries count. Those are like 501 and 500 in this case, so probably part of a page query. Shipping these off to Elastic, we can run some analytics on them. This is showing a big spike in visited object counts per 30 minutes here, and each of those big spikes in the environments corresponds with a different SharpHound DC only run. So another way we can get some visibility into potential LDAP enumeration spikes.
Awesome. So as Matt and I were doing red teams together and just looking through the different ways that we were potentially getting tagged or definitely getting tagged, some of the clients out there that we interacted with are definitely doing, either one of those things or all of those things, which made doing a red team assessment pretty tough because we're not able to do like really any querying of Active Directory except for like very tiny granular queries and spreading that out over a few weeks or a month or 2 months. And then having to correlate all of that, through manual log parsing, looking back, have we already queried this object? Have we already queried this group? What do we need to know to move forward with the op? So, to minimize our risk of detection, understanding these detection capabilities, we did move into kind of just use an LDAP search BOF from TrustedSec as the majority of our LDAP recon while we're on red team. So that let us control, what objects we wanted to look at, the attributes that we wanted from them, the scope of the search, so whether we wanted to search at our search base, which is just distinguished name, or if we wanted to go one level down from that or just see the whole subtree. And typically we would do pretty targeted queries to only bring back, less than at least 100 objects, but sometimes, most of the time, a lot fewer. And it was just kind of tedious. And some of the environments we were looking at were multinational, so there's tens of thousands of objects that we need to see, at least in the traditional sense, or we thought we needed to see. And it just, one night, just scrolling back through, Cobalt Strike log, looking up, going into the actual logs, looking at those, issuing another query. I'd be scrolling up in the Cobalt Strike window, and then someone would browse a file, and it would knock me back to the bottom of the window. It was super frustrating. And I just, thought there's got to be a better way for us to do this. And I said, we've already got all the information from LDAP. We just need to structure it. And surely we can just sling this into BloodHound and get the GUI back. So BOFHound was born pretty crude at first, just computers, objects, and groups, no ACLs, no anything. And then Matt came on and did some pretty amazing things with the tool and made it what it is today. But it is a offline parser that looks at your C2 logs or whatever tool you're using to collect LDAP information, parses that information, converts it to a BloodHound compatible JSON file, and then lets you upload it into BloodHound. So it is not a BOF that runs BloodHound. It is an offline tool written in Python. Probably could have named it something better to convey what it actually is a little bit, but we were using it in the context of BOFs, so that's just what we came up with. Originally built to bypass mainly that expensive LDAP query detection point, and built with compatibility in mind with the LDAP search BOF initially, and Matt's expanded that over the last year or so. So we support a few more tools now that we'll get to in a bit. But the way you would use BOFHound is this type of workflow. So you probably land in the environment in some space. You're curious about your immediate surroundings. You issue specific LDAP queries to look at the objects that you either control or are adjacent to or that you're interested in, right? And then once you get that information back, you would kick off BOFHound. It would read all those logs, and you would ingest those into BloodHound, start doing some path finding. And then once you run into an object or a path that you don't have full details on, whether that's, it probably is going to look like a path to a SID, you would then go back and requery for that specific object or related objects to continually build out your BloodHound data set without having to do so all at the same time. So it gives you really granular control. I say BOFHound does. Really, all these other tools give you granular control. BOFHound just makes it so that you can use that granularity in the context of BloodHound, which is pretty cool.
So we have a couple demos. Not brave enough to do live demos, so we've got them pre-recorded. and try and hook this back up so I can hopefully zoom in. We're going to take a look at kind of like a contrived example going through a couple of those enumeration cycles that Adam just talked about. So we're in our Cobalt Strike beacon, and we've got a singular beacon here as a low privilege user in the domain. We've loaded up the LDAP search BOF, and we're going to start with a couple really simple queries just for our target object. So, say we're interested in enumerating how we can get control over the domain. So we'll issue one query here for the domain object, and we're specifying that we want the NT security descriptor attribute back so that we can process that ACL data. So that's going to be the big base 64 blob that you see more towards the top of the query. And then the second object that we're going to query is just the domain admins group. So we can get really granular with this. We can query just one or two objects and then process that with BOFHound and load it into BloodHound. So that's what we're going to do here. Try and keep this on the action. So you can see there, we've processed those beacon log files. So those are just, your unstructured logs, basically mirror what you see in the console. BOFHound parses out those two LDAP objects. We can take that up here and, load it into the BHC interface, and I'll skip around a little bit. Okay, and if we go, so we've loaded up just the domain and the domain admins group. And if we take a look at the inbound controllers on the domain, we can see that we're missing some data. So we've got several different principals with control over the domain. The domain admins group is filled in there. And you can see that some of these other ones are, just basically a SID. So like this 516 is your domain controllers group. But that's an object that BloodHound does not actually recognize yet. We haven't queried it. So this is kind of like that starting point for walking back our ACL attack paths from a target object. So SIDs that show up here, at undefined, basically unqueried, are a good piece, as well as the member attribute of groups. So we queried the domain admins group. We don't actually have data on the members yet, but when we ran that query, we got back the member attribute, which contains the distinguished name of every user or nested group in there. And so we've added that to like the common properties that show up over here on the right side. So we've got SIDs of other controllers that we can kind of walk back, as well as distinguished names of group members that we might be interested in. So we're going to go back. I think I'm going to grab a SID here for the domain controllers group, that 516. Yeah, so I'll copy that out. We'll go back to our beacon. Try and zoom back in here. We'll issue, so we're going to start kind of like filling in that graph kind of piece by piece. And so obviously this is extremely granular. If you're going to query an entire domain, object by object, you're going to be around for quite a long time. So the sweet spot is going to be, issuing queries that return tens, 20s, maybe even hundreds if you're comfortable with that, objects. So we grab one user in the domain admins group and the domain controllers group there. We parse that out. So now we've got 4 objects that were pulled from our log files, slightly more ACL relationships recognized. And we can come back. It's going to happen to me every time. We can come back to BloodHound, upload that second set of data. And if we just kind of refresh this graph that we were looking at before, we can see we've added a little bit more to the picture based on the context we looked at previously. So you can see up in like the top left, we've got that user, Geralt, who's a member of the domain admins group, which grants him permissions to control the domain. And I think I'm looking around for the domain controllers group. It's actually one to the right of what I'm looking at. But yeah, there's that domain controllers group with the 516 SID that we know. It's got its properties filled in. We can see more about it. And so we can kind of keep walking back. If we take a look at one of the objects we just queried, we can see what its inbound controllers look like and kind of add to that picture. So that's obviously at kind of its most granular, querying just a handful of objects. We can go the other way and issue an object class equals star here. We can pull back almost all the information from the domain, 851 results. This kind of defeats the purpose of running a tool like this, right? We're trying to avoid those expensive queries that return a lot of results, but just for the sake of the demonstration, we can take that full run, parse out, 855 LDAP objects from the logs, and if we load that back into BloodHound, this should, in theory, be equivalent to like a SharpHound DC only pull. So we should have complete data based on all that processing there. And if we do a little refresh and look again at our domain's inbound controllers, we should see a much more complete picture. We won't be missing any of the SIDs in there. You can see there, there's a couple more objects that we, hadn't worked back to quite yet. So that's kind of, what that cyclical workflow that Adam was talking about looks like.
Before we move on from that, I just want to point out, he said it kind of defeats the purpose if you're going to just do an object star pool. Have spoken with some teams who did not want to risk detection with any .NET or .NET tooling, I guess, and so they have ran this to get the full picture of Active Directory, and it's a large organization, so it took like 30-something hours to process all the logs that came back. But it can be that for you if that's what you need to do. But the intended purpose, like Matt said, was do granular queries, build out your attack path piece by piece. And as we're doing that, linking back to some of the detection methods, we want to keep a few things in mind when we're doing these LDAP queries, because it can easily trip a detection if you're not paying really close attention to what types of queries you're running. So we want to look at search scopes and base names. So base name being the distinguished name from which you want to search, and the scope being either that base level only, the base plus one, so one level beneath it, or the whole subtree. We want to be really careful with wildcards, and I'll in the next slide I'll talk more to that. One thing to note is attribute presence filters make a really efficient use of the indices in LDAP. So if you're doing a query and you're just checking that an attribute exists on an object, that's usually a pretty safe query. But in all of your queries, you want to really be taking advantage of indexed attributes so that you can make as efficient use of those indices as possible. And I've included a link here that describes all the attributes that are indexed by default. But on the wildcard topic, there's a lot going on in this slide, but on the left side of the graph, the label's over there. The smaller label is the index that is used on the query. The larger text beneath that is the actual LDAP query filter that we used. So this is a wildcard case study. Same query, or a very similar query. Object class equals user, and same account name equals, on the top it's star A, on the bottom it's A star. So we're just changing the placement of the asterisk. And we can see, before we get to the actual results, the indices name is a little bit weird. We can see on the left it's IDX underscore object class colon 1677 colon N. So the way you would read that index, which comes back in the 1644 event ID log, the first field IDX underscore object class is just the index name that's being used. The second field 1677 represents the number of entries or the size of that index. And then the N, in this case, represents it's a normal index. It's not a custom index that was implemented. So if we look back at the graph, if we query with a wildcard in front of our search criteria, it throws the number of visited entries up drastically around the 1,300 mark and returns, just under 100 entries. So it's going to trip a couple of things, but mainly that inefficient query because our result set is less than 10% of our number of visited entries. However, if we do the asterisk after our search criteria, the number of visited entries gets drastically reduced. It's a much tighter correlation, and therefore we at least bypass that inefficient query based on visited entries. And something interesting to note is just that the index name that is used on these two queries is different. And it's going to be really important as you're exploring this to lab it out, and because there's not like a set criteria that I know of, at least that talks in detail about what index is going to be selected when. It all depends on your attributes and your search criteria. But on the top one, when we put the asterisk in front, it used the object class index. When we put the asterisk behind, it used the same account name index, which I guess is much more efficient. So it was pretty interesting to see that. The next query we're going to look at was even more interesting and not intuitive to me, at least. So the same setup. For all three of these queries, we use the filter object class equals user. But we had different starting nodes or base names and scopes for each of these queries. So the top search is the full domain as a distinguished name with the subtree scope. Second query is a specific OU, the admin OU, with a subtree scope. And the last query is the OU, again, with a one-level scope. So if I were to just have thought of this, I would assume that the tighter your base for your search, the more efficient the query is going to be. So I would have assumed that searching directly within an OU with the subtree scope is going to be more efficient than searching the whole domain with the subtree scope, and that wound up not being the case. We can see that the object class index was again used for that domain subtree scope. And when we switched to the OU subtree, it switched to a different index, which has a smaller size, but then had a little bit more visited entries versus returned entries than the domain search did. So that was something that was interesting to me. Obviously, if you get down to one level scope with a tighter base, your results are much smaller number of visited entries. Obviously, a smaller number of returned entries because it's got less to search within, but pretty tightly correlated. So I guess the point of this slide is just it's not always super intuitive based on your filter and your query what's actually going to happen under the hood. So having a lab, at least in my experience, is very important for understanding how efficient your queries are going to be and what kind of results you're going to see from that. Last thing for me, we just wanted to throw up a couple of helpful queries, and then I'll pass it back to Matt for some more demos and some talk of where we're going with the tool. You're always going to want to get the NT security descriptor. If you use LDAP search BOF, you can get all the attributes with star, but always include that NT security descriptor so that you have ACLs on the objects that you're looking at. OU walking is something that was mentioned in a recent blog by MDSec. Got it footnoted at the bottom. Definitely recommend checking it out, but that's a filter query for how you could, or query filter for how you could do that. Using search bases, just again, another example of how you would assign a search base to your query if you're using the LDAP search BOF. Unrolling group memberships is actually a pretty interesting one. You can see that we're maybe you can't see from where you're sitting, but on the slide, filtering based on member of and providing an OID that basically allows you to do an in-chain search match. So there's 3 OIDs that I know of. You can do bitwise and, bitwise or an in-chain rule, and that's gonna recursively unroll the group membership for the object that you're querying. And then similarly, the query below that, you can use a different OID with the bitwise operations. I think that's a bitwise and there, looking for user account control set equal to trusted for delegation. So you just give it whatever decimal value you want for the UAC of the users or the objects you're looking at. And you can use that to do some bitwise operations and really granularly specify what types of accounts you're looking for. And then finally, if you need lapse information, there's an example down there to pull all the schema information that you need to see lapse in BloodHound as well.
So up until this point, we've been talking exclusively about LDAP data and ACL-based attack paths. And if you're familiar with BloodHound, you know that a large component of the attack path mapping revolves around like local computer data, so group memberships for who has admin to what computers, RDP edges, and your like has session where is a particular user logged in and what accounts do I need to compromise to kind of gain access to the machines where they might be logged in with. So we do have this capability built into BOFHound as well. We'll take a look at that. So you could use this. You could use this with the LDAP search BOF and some of the enumeration routines that we've talked about. Another interesting option that this opens up is the potential to collect a DC-only run with SharpHound if that's something you have the capability to do. But maybe you don't want to go spray an SMB connection to every machine in the entire domain. That's significantly more risky than just pulling LDAP data with SharpHound. So if that's something that if that's a scenario that you find yourself in, it is possible to manually collect that local group and session data with BOFs and then parse that data out with BOFHound and kind of supplement a DC-only pool. This is very similar to using the computers file flag with the SharpHound collector, just kind of specifying specific machines that you would want to collect that data from. So we've got a full DC-only run. I've cleared out my LDAP search results from our beacon logs here. So we've got like a clean slate. We've uploaded a full DC-only pool, so no sessions, no local group data or anything like that in our BloodHound database. And there's a couple other BOFs included in the Trusted Sec Situational Awareness BOF set that will let us enumerate this data that we're looking for. So we've added a couple secondary. You can see like the one here being run as net local group list members 2. But that will allow us to pull out group data for the 4 groups that, the 4 local groups from a computer that BloodHound cares about. So you can see here, we can pull out the administrators for a machine, and we've got that SID. Most of these local group relationships and session relationships in BloodHound are comprised of 1/2 computer SID and 1/2 user SID. Second piece that we're going to be looking for is who's logged into our target computer Oxenford. So there's a couple BOFs that can do this. One of them is net logged on 2, which is providing, you can see SQL service account is logged into this target host. We can do this through net logged on 2. We can do this through net session 2 and also the reg session BOF. And these are just basically using different Win32 API calls to enumerate who's logged into the target machine. Most of the time, these are going to require administrative rights over the target, just like if you were running SharpHound. So one of the nice things about the reg session BOF is that it's going to pull back. Trying to zoom out real quick. The reg session BOF will pull back. It's not quite as aesthetically pleasing. You don't actually see the username of who's logged in, but you get the SID, which is a little bit easier for BOFHound to parse. So with that, if we're going to try and take this data that we've enumerated so far and augment our DC-only pool, a little bit of data we're going to need from LDAP is just the domain SID. So issue an LDAP query for the domain there, just grab that SID, and then the computer SID to make up those other half of the relationships. So we'll query that computer. We can, again, take this over to BOFHound, and we'll see only two LDAP objects found in the logs, but we'll see a bunch of local session or local objects. So we got like 3 registry sessions, couple local group memberships. And if we go back to our BHC interface, I think this is just verifying that our current DC-only pool includes no session data. But you can see we've got a pretty clear picture of the rest of the domain. If we take a look at that one target computer that we were running some of the local object BOFs against, we don't see any sessions or administrators there. If we go ahead and upload the output from our most recent run, so we can see we've got 3 sessions now in the database. There's 3 SIDs that came back in the reg session BOF. If we take a look at one of those, I think we get a little bit of a web error here. But taking a look at that SQL service account that we know was logged into that target machine, we can see, we've successfully added this data to our DC-only pool. So we've got a has session edge there, and we can take a look at that computer object and kind of rotate that around. See, we've got 3 sessions, and we've also got some local admins to this box, 2 explicit, 5 nested via the domain admins group. So this is another possibility as well. You could, again, like I said before, you could run this with your normal LDAP search enumeration routine, but also potentially supplement a DC-only pool. So that's it for the demos. A little bit about the current state of the tool, as well as some future ideas. So what all can we parse with BOFHound? So it's kind of categorized into session and local group objects and LDAP objects. So on the LDAP side, we've been talking exclusively about the LDAP search BOF. Obviously, there's a lot of tools that can make LDAP queries and spit out raw text data. A couple that are very similar to the LDAP search BOF are going to be PyLDAP search and BruteRetel's LDAP Sentinel. Both of these can be parsed by BOFHound. A really interesting one is ACED. This is a tool by Garrett Foster. There's a link to it on the final reference slide if you're interested, but it provides kind of like an interactive command line to perform that ACL attack path mapping, like walking back from a target object. So in your interactive shell, you can input like a same account name of an object to query, get a quick listing of the inbound controllers and which ACL or which right they have granted over your target object, and then quickly issue queries for those objects and kind of walk those back. And this outputs the same logs as PyLDAP search, so you can scoop those up with BOFHound and turn them into something that you can view in the BloodHound Community Edition interface. For session and local group objects, this is a newer feature that we've added support for, so this is only going to be supported with the BOFs there that we already talked about a little bit ago. So some pitfalls of BOFHound and kind of this approach, kind of hand in hand, niche use case and time and labor intensity. So there's going to be a lot of scenarios in which you don't have to worry about stealth when performing LDAP enumeration. If you're doing a pen test, this is probably something you don't have to worry about. Even on a red team, you're oftentimes not privy to what type of detections the blue team has in place for LDAP reconnaissance. So this may be something that you want to use at first. Taking precaution, but later in the engagement, you might have to take some more risks. This is obviously a lot more, like manually intensive than just running SharpHound and then looking at your attack paths in BloodHound. And then on the more technical side, memory consumption. So Adam made reference to a fairly large LDAP search BOF pull that pulled back tens or even hundreds of thousands of objects. Right now, BOFHound does all this processing and kind of like the correlation between objects in memory. And so if you have a lot of LDAP objects in your logs, you can either cause Python to run out of memory, just kind of crash, or you'll end up with one of those pulls that takes 35 hours to process. Some stuff that we'd like to do in the future. So Andy and Jonas had a great talk today about some of the new Active Directory certificate services data and attack path mapping that has been added into the newest version of BloodHound. Right now, BOFHound does not support ADCS data parsing and edges. Got a couple new object types to map there, but this is something that we'd like to add in the future. Kind of along that memory consumption pitfall, we'd like to reduce this in the future by using either like a temporary on-disk database or potentially direct interaction with the BHCE API. This opens up some interesting possibilities. We already have code for near real-time log monitoring. So, as you're querying objects via your C2, you're populating those beacon logs, just having those scooped up every 5 minutes, every 10 minutes. And if we were able to get this integrated with the BHC API, this could allow for some pretty seamless transition between you just making a query in your C2 and then just popping over to your BHCE web interface and already having that data and those relationships populated. And that is all we have. There's a reference slide here with a lot of the tools that we talked about throughout this presentation. Too many to just put at the bottom of footnotes. So if you're interested in anything that we mentioned, links should be here. And with that, thank you for coming. And if you have any questions, we'd be happy to answer.
Sure. Yeah. So I was really happy to hear you talk about, I didn't even know BloodHound Community Edition had an API, so that was news to me today. So from my understanding, it sounds like you could upload data, like the way that your Python script is working, to then update that. You can do that like on a time interval, and that would be pretty seamless. But have you put any thought into potentially making like an aggressive script that on the output of like your BOF, like the LDAP BOF, it automatically calls your Python script so that every time you get data back, it automatically and instantly gets uploaded. Granted, if you have the API with it, because then it would just be a really seamless process if you wouldn't have to run the Python anyway.
Yeah. So a question there is, with the addition of the API to BloodHound Community Edition, have we considered creating like an aggressor script for Beacon so that when we issue an LDAP query, the aggressor script will automatically run BOFHound on the back end and can make that, can process that data and upload it straight to your BloodHound web interface? I guess we haven't necessarily thought about an aggressor script to do that. The line of reasoning being that, especially as your pool of LDAP objects grows, it can be very time consuming to run that ACL parsing over and over and over again. And so while it would be pretty seamless and it shouldn't be an issue with a smaller number of LDAP objects, it just doesn't scale very well to be repeatedly doing that parsing. So, with the CE API, the ability to like granularly pull back data from it, so kind of build those relationships potentially still in memory and then upload that JSON. That's kind of more of the route I think we'd potentially take. Anything to add there? Okay. Thank you. Good question. Okay. Well, thank you again.